So we're going to talk about mixtures today, and specifically a heterogeneous mixture. Now, the first thing you need to know is that there are two types of mixtures, heterogeneous and homogeneous. And here today we're talking about heterogeneous. Hetero is a Greek prefix meaning unlike or different. And so here, a heterogeneous mixture is you're going to be able to see, or you can easily separate the different parts of the mixture. So let's get right to it. And the first picture I always like to use for a heterogeneous mixture is a pizza, because it illustrates it so well. And this pizza looks absolutely delicious, but more important than its taste right now is the fact that it's heterogeneous. And you can see here we have a tomato, we have a bell pepper, we have some mushrooms in here, we have cheese, we have a crust. All of these make up the pizza. So the pizza is a mixture. And these are physically mixed. In other words, there are no chemical bonds holding the tomato, binding the tomato into the pepper. Each of these different phases, I'm going to call them phases, retain their properties. Okay? So we have a tomato phase, a pepper phase, a mushroom phase, a cheese phase, a crust phase. They all retain their individual properties. And that's what makes it a heterogeneous mixture. Now there's two types of heterogeneous mixtures. The first is a suspension, and the second is a colloid. And it basically deals with the size of the particles that are in the mixture, that are in the heterogeneous mixture. Suspensions tend to have relatively large particles, generally greater than 1,000 nanometers. And so what happens is when you have a mixture that settles out upon standing, if it settles out like this container here, we see that we have two phases, here and here. And so that is what makes it a suspension, okay, because it can settle down. Now, to identify a suspension, you can always filter it. And by filtering it, you'll separate it into the you can separate it into the different parts. Okay. Now, the second type of heterogeneous mixture is a colloid. And colloids have slightly smaller particles in them, 1 nanometer to 1,000. Okay, so they can stay suspended in the dispersion media, whatever substance. This is the what's doing the dissolving. Okay, the dispersion media can suspend the particles, and they're not large enough to settle out, so they do not settle out, but they are large enough to scatter light, and we will talk about that shortly. Colloids cannot be separated by filtering, so this is something that's different from a suspension. This is how you can tell a colloid from a suspension. Colloids, generally, these particles are too small to be filtered out. Examples are whipped cream, like I have here. Whipped cream would be air and a liquid, so it's a liquid gas colloid. Okay. By the way, not all mixtures are all made up of solids, solid in a solid, or a liquid in a liquid, or a gas in a gas. You can mix your states of matter. So in whipped cream, we would have a liquid in a gas. Milk, mayonnaise, jello, marshmallows. Marshmallow is sugar in air. Those are colloids. Okay. Blood is a colloid. Now, what causes these particles to stay suspended? And what I'm showing you right now is a actual microscope video of some nanoparticle. Oh, they're 88 nanometers in size, just vibrating randomly in probably water. And this is showing you Brownian motion. Brownian motion is named after the fellow that first observed this under the microscope. And he saw this random erratic motion, and it's caused by these colloidal particles bumping into the dispersion media. Okay. Well, what causes this Brownian motion and what keeps the colloidal particles suspended in the dispersion medium oftentimes is the fact that those colloid particles are electrostatic. Okay. Electrostatic in nature. That means they have a charge to them. And so if they have a charge to them, they're going to attract other unlike charged particles or repel like charged particles. So that's rather important in keeping a colloid a colloid. The two main reasons why you have colloids is because of this electrostatic attraction or repulsion, and then also because of the size of the particles. Now, the next thing we want to discuss briefly here is the Tyndall effect. And the Tyndall effect is a test that you do to determine if something is a suspension or a colloid, as opposed to a homogeneous mixture. Remember, suspensions and colloids are heterogeneous. Okay? The Tyndall effect is the scattering of light by particles. And I told you that even though colloid had small particles, they were still large enough to scatter light. Anytime you see a sunbeam like this is the Tyndall effect. It's where light bounces off the tiny little particles. There's a bunch of tiny little particles in here, in fog, and that's actually water droplets. And they reflect the light off, and that allows you to see the sunbeam. Okay, this is where we're actually doing it in the lab. So this has some water in it with a few drops of milk. Now, milk is a colloid. Okay, when you shine a flashlight through this, you see the beam all the way through it. And so this is a positive Tyndall effect, telling you that that mixture in that beaker is a colloid. This is a negative Tyndall effect. And you see the light reflects off the glass here and it reflects off the glass here, but you do not see that beam of light. So this is a negative Tyndall effect. And this would indicate that it is not a colloid, it's not a suspension, that it is actually a homogeneous mixture, which is the solution. So both suspensions and colloids will have positive Tyndall effects. You can also show this if you clap chalk dust in a flashlight. Have a flashlight shining and you clap chalk dust, that dust in the air shows the Tyndall effect. You can actually see the beam of light there. Okay, well, let's look at a few more examples here, just to review a little bit here. So I had the first one, I have fog, and fog, as we just said, was a colloid. It's air droplets in water, and it's water droplets in air, and that's a liquid in a gas, water droplets in air. So that's a colloid, doesn't settle out. Smoke is also a colloid. You have small particles here that stay suspended in the air, and so that would also be a colloid. Again, both of these would have a positive Tyndall effect. And both of these you would not be able to filter out the particles. Volcanic ash, when a volcano goes off, you get this pyroclastic emission, and this is a suspension because you will have that ash. Those ash particles are large enough so that they will settle out. When the wind stops, when that initial blast slows down or the wind stops moving, then the ash will fall, and that is a suspension then. You have a solid and a gas. And then here's another example, especially in the South, people like to put peanuts in their Coke. And the peanuts will go in there and then they usually bob up to the top and eventually they'll sink. Well, because they will separate out easily upon settling, then this would be a suspension, and it would be a solid in a liquid. So we've gone over two types of heterogeneous mixtures, suspensions and colloids. And a heterogeneous mixture, if you remember, you can easily separate the parts of the mixture out. They have more than one phase.